Hi everyone. I wanted to kick things off this morning with a brief discussion of some of the outstanding science questions concerning lunar volatiles. This presentation is inspired by a white paper that some of us put together recently for the Decadal Survey, and like most white papers, it's based on the work of many of our colleagues. So if we go to the next slide. We are currently in the middle of a revolution in our understanding of lunar volatiles, and like many great revolutions, this one is far from complete. Towards the beginning of the decade, those tiny green glass beads in Apollo 15 samples told us that the lunar interior contained more water than we previously suspected. And shortly afterwards, a trio of spacecraft went on to discover widespread hydration across the illuminated lunar surface, as well as in permanently shadowed regions near the lunar poles. LRO has observed the moon in a variety of different lights over the last 10 years, and like all of the best missions, it's raised more questions, or as many questions as it's answered. If we go to the next slide. The science of lunar volatiles is not just compelling lunar science, it's also fundamental solar system science. The interior volatile content of the moon tells us a story about the origin of the Earth-Moon system. For the last several billion years, permanently shadowed regions near the poles have recorded the history of volatiles in the inner solar system. Then there is the global hydration signature, which tells this strange tale of how sunlight might create water from rock, and that tells us something about the distribution and origin of water on other bodies as well. The lunar poles are home to some of the coldest places in the solar system, and there is no more accessible environment in which to study chemistry and a range of other surface processes under really extreme conditions. And then there is the lunar exosphere, that thin, tenuous, surface-bounded exosphere that informs our understanding of so many other atmospheres of that class across the solar system. Next slide, please. And there are so many questions that remain to be addressed. Some of these are really fundamental. We still don't have a firm handle on the composition, concentration, distribution, and physical form of polar volatiles. In particular, what is the nature of that hydrogen that we see in the polar subsurface? And there are significant gaps in our understanding of volatiles other than water. Isotopic composition has still never been measured. We go to the next slide. What's the origin of polar volatiles? We know that impacts, volcanism, and the solar wind have all sort of whispered their stories into the polar regolith over time, but we don't completely understand how those sources and the polar environment itself has varied across time. In particular, there's this increasingly intriguing question of why Mercury appears to have so much more abundant water ice. We see volatiles at different depths. How are those connected? Thanks, Ariel. Next slide, please. The poles are a dynamic environment, and we're still in the process of understanding some of the processes that operate in that environment. Space weathering, whether that's impact bombardment or plasma sputtering, volatile transport, and chemistry are all thought to play a role, but they still remain to be studied in situ. Next slide, please. There are also outstanding questions regarding the distribution of physical form of volatiles beyond the poles, including the hydration signature and those volatiles that are locked up in the rock. And on the next slide, we have outstanding questions about the contemporary lunar volatile cycle, including the components of that cycle and how the exosphere responds to changes in the space environment. Next slide, please. This is why one shouldn't put every bullet point on a separate slide, but one of the most intriguing questions over the last decade is how the lunar atmosphere has changed over time. Were there ancient atmospheres due to volcanism or impacts or outgassing? What happened to them, and are there any traces that remain? And then one final question on the next slide is the question of resource viability, which is something of scientific and more practical interest. And addressing that question has overlaps with a lot of the other questions, but also some distinct aspects of its own, such as what contaminants might be present when we think about extracting lunar water and whether it's a renewable resource. And then one final slide. The next decade looks to be just as interesting as the next. And I think one thing to keep in mind as we go forward is that the poles are like nowhere else in the solar system that we've been before. This polar microenvironment, it's ancient, it's dynamic, it's strange, and it's beautiful. We will change it when we visit it, and we should plan for that in our science and operations, but we have so many different ways of doing science, and we're looking to strengthen the collaboration that we built over the last decade. And I very much look forward to seeing what all of you go on to do, not just in the course of this workshop, but over the next 10 years. Thank you.